guys, this is Anna, Annie, and Chris with number 1 from homework number 5, parts A and B. We'll start off with part A. So we'll suppose we have a partition for a particular function between the intervals of closed interval of A, B. What we'll do is we'll take that partition and redefine it with P sub star, which will contain of this entire partition plus some element X, which we'll put in between two other elements in the original partition. With that, what we want to prove is that the lower sum of the original partition is less than or equal to the lower sum of the redefined partition. So here is our proof. We'll start off with a definition of the lower sum given to us as the sum of all the m sub i's delta alpha i's, where m sub I is the infimum of each of those partitioned elements. We also know that alpha is monotonically increasing, therefore the delta alpha I is basically the difference between the larger minus the smaller bounds. So we'll again state that m sub I is the infimum, and that we'll use for the original partition, but then we'll let w sub 1 be the infimum between the left part of the partition, in other words between x sub I minus 1 and x star, and w2 be the infimum between x star and x sub I. Now we do know that both w1 and w sub 2 will be greater than or equal to m sub I. Why? Because the interval for m sub I is a larger interval than each of the intervals for w sub 1 and w sub 2, and those are the intervals. Let's look at this information visually. So here we have a monotonically increasing function, f of x, which is partitioned into smaller elements here, x sub 0 through x sub 6, as you can see. Now, if we were to take each of those partitions and look for the infimum, here we have m sub 1, here we have m sub 2, m sub 3, and so on. And the sum of all those infimums is what our lower sum we are presenting in this proof. Now, if we now take a closer look at the redefined partition, here we've entered an extra element dividing this partition into two smaller partitions. And again, the W1 is the infimum of the leftmost partition, and W2 is the excuse me, infimum of the right side of the partition. And again, as we said earlier, the m sub I is a larger interval, therefore the infimum of m sub I will be greater than the infimum of w sub 1, oops, that should have been 1, and w sub 2. All right, the lower sum of the redefined partition, which will consist of all those infimums, m sub 1 delta alpha 1 plus m sub 2 delta alpha 2 through m sub n delta alpha n. But in that, we also had the two smaller partitions, w sub 1 and w sub 2. Then we'll also take the original partition, which was m sub 1 plus m sub 2 plus the m sub I through m sub n delta alpha n. Let's subtract those two, and this is what will happen is if we subtract them, these elements will cancel out, leaving us with just these three elements. So it will look like this. The difference is w sub 1 delta alpha 1 plus w sub 2 delta alpha 2 minus m sub I delta alpha I. Now, from the definition, and because this was a monotonically increasing function, we know that delta alpha I is alpha x sub I minus alpha x sub I minus 1. since W1 was between x sub I minus 1 and x star, we can rewrite this one as Wi and the difference, alpha x star minus alpha x sub I minus 1. And then looking at the interval for W2, which is between x star and x sub I, we'll do the same for W2. And then use this original for m sub I. What we'll do next now is rewrite this part for W1 and W2. And also keep the m sub I, but in the middle here, we'll insert a 0, which is going to be in the form of a alpha x star plus alpha x star. So both of these obviously add to 0, so we're not changing the expression. Why am I doing this? Because now, if I were to group these together, x sub I minus alpha x star matches this part here, and alpha x star minus alpha x sub I minus 1 will match that part here. So we end up with that here. Now, as I said before, watch this. This part here matches this part. Let's just take a different color. And this matches that. So we'll reorder these expressions so that they're next to each other. So this W1, which was matching this m sub I here, can be placed together. And then W2, which was matching this one, can be placed together. Now, since this, let's do it this way. This matches that, I can factor that out from W1 and m sub I, leaving us with this expression. And then same thing on the other side. This matches that, so I'm going to factor that out, leaving us with W sub 2 minus m sub I. All right, now at this point, we do know that W sub 1 and W sub 2 are both greater than m sub I, which means that this part here, where's my mouse? This part here is going to be positive, and this part here, since m sub I is less than W sub 2, will be positive. And since alpha is monotonically increasing, we can conclude that this expression here, which is what we have here, has to be greater than 0. If that's greater than 0, then that means this has to be less than the redefined partition, which is what we wanted to prove in the first place. So that completes number 1, part A. I hope that was clear. Now at this point, part B. In part B, it's the same exact thing, except that this time, instead of we're looking at the lower sum, we're looking at the upper sum. So we want to prove that the upper sum of the redefined partition is less than or equal to the upper sum of the original partition. So in our proof, again, we have our definition of the upper sum, and instead of the infimum as we had in part A, we actually are looking at the maximum supremum in part B. Again, it's a monotonically increasing function, therefore delta alpha I is alpha x sub I minus alpha x sub I minus 1. We'll let m sub I, capital M sub I, be the supremum of its interval, and we're going to let capital W sub 1 be the supremum of the smaller partitioned interval or redefined partition interval, and W2 be the supremum of the redefined partition interval on the right hand side. Again, both of those will be smaller than M sub I because the interval for M sub I is larger interval than each of those. We'll consider, pressed too quickly, sorry about that. But once again, we'll consider each of those, the upper sum of the original minus the upper sum of the redefined sums. And if we were to list those, you can see that we have terms that will cancel out, leaving us with just that middle part here. So the difference between those two is that. Again, we are going to rewrite it as before using the definitions, as you can see, and then we'll take that part and insert this 0 here again so that we can have matching expressions. And that's what we have here. So we have this part here, if we were to group this, divide this into groups, matches that one, and these match as well. Putting them together, we end up with this. And then once again, because we have matching expressions, we can do some factoring. And again, since M sub I was greater than W sub 1, this will be positive. And M sub I is greater than W2, this will be positive. And since alpha is a monotonically increasing function, we can conclude that the upper sum of the original partition minus the upper sum of the redefined partition is greater than or equal to 0. Therefore, this redefined partition has to be less than or equal to the original partition, upper sum of the original partition. Hope that was clear. This concludes number 1, and we'll see you guys soon.